but it's going to be very short. Okay. So I'm going to start with the review, exam review first. I'm going to close the monitor for a second. I just wanted to make sure that solution is in. I'm not going to open the PDF. Okay, so as you can see, there is a typo here, right on the first page. Can anybody notice?
It says exam here.
Exactly, very good. It's going to be final exam. So it is going to be final exam. I'll fix it. It is going to be final exam. Okay, and our exam is on May 9th, right? Saturday at 2:30 p.m. And our exam is going to be in the same room that we have been having. Okay? Junior lab, which is BC 4260. I'm going to send you an email. So it is going to be same lab that it is having exam. So yeah, I will send you an email anyway. Now we have we have 8 pages and 6 problems. I'm still modifying a few problems. 6 problems and permitted materials. You want to bring 1 page of formula sheet or 2 pages?
2 pages.
It's okay for me having 2 pages. So 2 pages, 8.5 by 11 inches. Okay, both sides. 2 sheets of paper, both sides. Okay, so you can bring that. And then so point distribution is going to be like 15, 15, 15, 15, 15, and then last problem is 25. Okay, so I'm going to start with the last part of the course material. As you can see, I will be emphasizing more on the last chapter of the textbook, or last parts of the lecture materials. Okay. So let's start with the last part, whatever I went through. So from this Kalman filter 1, I went through the theory. So you will have numerical problem. You may expect a numerical problem very similar to problem 1. Okay, so as I said that this problem is meant to be using computer for time t equals 0 to, for example, 60 seconds. But in the exam you will not have computer, so I will be giving you all the parameters, even some noise, process noise and measurement noise. I will be giving some process noise and measurement noise. You may need to just apply the prediction and update step, to predict and update the vehicle's position and velocity and state error covariance matrix for up to 2 to 3 time instance maximum. Okay, so it's an iterative process. As you can see, it's an iterative process using this algorithm, maximum 2 to 3 time steps. So this is quite important. And from the stock market one, so focus on Brownian motion only. Focus on Brownian motion and see how the Brownian motion is modeled. And of course, I'll be giving you some numerical example. So you'll be utilizing all of these, and then finally you will make use of the solution of this E2 stochastic differential equation. E2 differential equation, or people, it's named after scientist Ito, Japanese scientist, mathematician. E2 differential equation, and in general it is called stochastic differential equation. You do not need to know how to solve this stochastic differential equation, because I gave you the solution right here. And this solution you are basically using in your last computer assignment with the initial stock price of QCOM, and then based on the last 5 years data, you determine what is mu and sigma, and then you estimate mu and sigma using the log literal equation that you have here. So you have mu, sigma for daily, and then you just multiply them with 252 and square root 252 to determine mu and sigma. And then you can use this mu and sigma directly here to determine the stock price at time t. Of course, it's a discrete time stochastic process because we will be estimating the daily closing price of Qualcomm for the computer assignment for next 5 years. Did you guys read my announcement? I did send an announcement regarding this details instruction.
For computer.
Yeah, computer assignment. So read that announcement. So it's you just use closing price of April. I did send an announcement on April 29th. Okay. So April 29th. From April 29th, and you go back 5 years. You collect all the 5 years data closing price, and then you estimate the closing price of Qualcomm. Okay, please excuse I'm not quoting Qualcomm, but for the sake of assignment. So this Qualcomm, you will be estimating the closing price of Qualcomm using this geometric Brownian motion for next 5 years, which means that we are in 2026, and it is going to be 2026 plus 5 is 2031. So it is going to be April 29th. April 29th, 2031. Okay. It's in the email, in the announcement. So I made it very specific, but please do let me know if you have any question. All right. So, and in the exam, if you have this sort of problem, again, it's going to be up to, like, for example, I give you some data, some small sample data, and then I may ask you what is mu and sigma. You estimate mu and sigma, and then probably 2 or 3 stock price you estimate. So that's the most important topic. So the other part is in case I plan on giving some true false type questions. So from section 2, so you may expect some true false type questions. So I do not have any numerical example, you may expect some true false type questions, that's all. But as far as the numerical problem is concerned, So it's going to be just Brownian motion, this P2 differential equation, solution of P2 differential equation, and the one that I went through today. Okay, and so that part, and then you go through chapter 8, which is central limit. Chapter 8, which is basically confidence interval. Confidence interval, very important. Estimating resistance from noisy measurement. So I have one example and solution as well. So I gave another example, another problem, and you may want to work out this example. So estimating model parameters. And then I will move on to part 3. I actually went through the details of this in my notes. Here in my slide, one extra thing I have is geometric Brownian motion. You can just for your computer assignment, as well as in case you have some Python. Okay. Again, in the exam, I do not give any plot information. I do not ask you to write comment for plotting. Just this sort of comments and how to initialize parameters. You actually saw how I give some Python related question. Okay. So for computer assignment, guys, you may want to start using this equation as the starting point. Okay. So what you have to do is collect data. So you have to come up with this mu and sigma based on the data. Okay. So you may want to modify this code and work on the computer assignment. So this is very helpful for you. Then, yeah, I'm going backwards, guys. As you can see that the last part is going to be the most, I'll be emphasizing mostly on the last parts of the course materials. So we have covariance, autocovariance function, but what you do, autocorrelation, we went through all of this, but make sure you go through the homework assignment. See that homework assignment that I posted, right? That is due tomorrow, homework assignment. I included all the examples, okay? Make sure you solve all those examples and all the homework problems, then you will have clear idea. But as you could figure out and as you notice, I do not ask you to write any formula. So these formulas you can just bring with you in the formula sheet. So I will just probably give you some numerical values of some parameters and ask you to find what is the autocorrelation, for example. Here. From random processes, these slides, you just go through these slides for true false type questions only. For true false type questions only. Other than that, I do not have plan on generating numerical problem on these slides. Just true false type questions. And these examples, in addition to some other generated problems, really very similar problems in the homework assignment. Make sure those homework problems is solved. You will see this example is part of the homework problem as well. So make sure you solve that. And yeah, that's all from this part. And then let's move on to part 2, statistics. yeah, statistics. Yeah. From part 2 up to slide number 239. So up to slide number 239, after that you do not need to even study. So just for your knowledge you can go through, but for the exam, after slide number 239, I do not plan on giving any problem after slide 230. But from this part, second part, yeah, this example is very important and I give you the solution. Make sure you read it. Guys, please, when I have the example and solution and there are some homework problems, okay, some examples that I work in class and some of you wrote the solution, please do not simply skim over the solution. You take a piece of paper and then do it. That will help you. Okay, if you simply skim over, then you will see the problem will arise in the exam. Okay, if you simply just skim over, please do not skim over. Take a piece of paper and pen, and you have the solution. Some of them you have the solution, and you redo it on a piece of paper. Confidence interval. How to make use of confidence interval? Actually, some of these equations you directly apply right here. In this example. So this is one formula, and how to come up with this Z alpha. How to come up with this Z alpha. And for this section, guys, for this section, there is a table. There is a table in the textbook. Please make a note of this one. I'm going to open this textbook. It's available online. And I'm going to show you the table that we get. In addition to Q table that we got. So it is chapter 8. It is the critical value table, guys, table 8.1. So make sure you bring this table. This table will be helpful. And all the formulas I actually took some of these formulas in my notes, but this table I did not put it in my slide. So make sure how to find this critical table. This is given in the table.
Did we also bring the Q table for this one?
Yes.
Yeah.
Yes, I'll go. That is in chapter number 4. I'll go there as well. So you bring this critical table. That critical table will be helpful for you to determine Z alpha by 2 directly. And I went through this example here in class. And then from chapter number 7. From chapter number 7, central limit theorem. From chapter number 7, yeah, see this example 7.11, okay? Very similar to this example, very important. Okay? Make sure you solve, and I put this example and some relevant examples in the relevant problems in the homework. Make sure you practice those. And yeah, this central limit theorem, some short question in the form of true false type question. Okay, so make sure you understand the meaning of sum of n random variables and sample mean of n random variables. Okay. So So yeah, this central limit theorem is very, very important, this topic. In chapter number 7, three sections that I went through laws of large numbers, I went through Chebyshev inequality, and you actually need the Chebyshev inequality. I went through this example as well. Okay, go through all of these examples, but among all the topics that I have in chapter number 7, so which is basically part 2 from chapter 7. Here, these are just for true first type questions, and as you can see that I went through sample mean, laws of large number, central limit theorem. So among all the topics, okay, central limit theorem is the most important topic that you guys should focus on. So this is from part 2, and then let's move on to part 1. Part 1, yeah, please take notes. Part 1, forget about chapter 1. I will not have planned giving even true false type question from chapter number 1. Okay, so forget about chapter number 1. Let's move on to chapter 2. From chapter 2, you just focus on just the examples, a few examples, and do you have the solution of exam 1, guys? I provided the solution, right? So make sure from part 1, what you going to cover from chapter 2, make sure you go through those problems. Okay. Again, please do not simply skim over the solution that I gave you. Okay. So I gave you the solution. You see the problem, take a piece of paper, and then read it. Okay? So, from chapter 2, just the examples, you even don't need to go through the end of chapter problem. Okay? So, just the examples that I have in my slide, and the problems we have from exam 1. So that's all you focus on chapter 2. Now, as you see that I am moving on to chapter 3. Quickly. Yeah, I'm moving on to chapter 3. So from chapter 3, yes, I plan on giving one numerical example. And that numerical example could be from many topics, but among all the topics, I'm going to show you. So go through all these examples, by the way, because you do know this background, this PSA. So this is going to be, I'm talking about the PMF, this probability mass function. So PMF, this topic is very important. This is based on discrete random variable. So this PMF is very important. Now, you apply this PMF, you use this PMF, go through Bernoulli, binomial, and geometric random variables only. Bernoulli, binomial, and geometric random variables only. So we went through these examples. These examples make use of probability mass function of different random variables. Also, just like what you have seen in exam 1 and exam 2, you have short Python code, and actually some of you, most of you did well in the Python code. So I do not plan on giving Python code where you have to write, you have to plot, or you have to probably like some parameters, how to define parameters C. So I give you comment like this, and then I ask you to define parameters. So read the problem clearly and see what parameters are given, and then you write down the parameters. Okay. And I will limit the Python code, the syntax related to the Python code based on the Python code that I have in my slide only. Okay? Only the Python syntax that you see. For example, there are several modules that I use, binom module. For example, binom module we have PLL. See the parameters and make how to make use of these parameters to get PMF values, for example. So these are the only syntax that I will be focusing on. And then we have Poisson random variable. We have Poisson random variable, again same comments. Poisson random variable. Now we move on to expectation. Expectation and mean variance, very important, guys. You had similar problem in the exam. Expected value of functions of random variables. Expected value of functions of random variables. Square law device. I went through this example. So here as well. So mean and variance is the most important topic for the expected value moments of discrete random variables. So from this topic, mean variance related problem, very important. You see that variance here. So how I calculated variance, mean and variance related problem would be the most important problem. The conditional probability mass function, do not even worry about this conditional probability mass function. I removed this topic from the other exams as well. So I did not go through these topics in class, so therefore I do not plan on giving any of these topics. So now, binomial random variable in your formula sheet, you may want to just small one portion, you can just write down the binomial random variable mean and variance, binomial random variable mean and variance, Poisson random variable mean and variance, uniform random variable mean and variance. And then we move on to chapter 4. So chapter 4, as you can see, as we are moving on different chapters, so more and more important topics, I will be emphasizing more and more. So less emphasis will be given to initial chapters, more emphasis given to later chapters of the module literature. So we have the random variable, one random variable, continuous random variable. Here, the most important topic is the cumulative distribution function, CDF. And then you go to PDF, probability density function, and then probability density function, we went through many random variables. Make sure, guys, you know the syntax here, uniform, PDF, CDF. So you know how to use these parameters. So namespace, PDF, CDF. And then don't worry about the plotting at all. So for example, here from this piece of code, from this piece of code, on these three syntax, namespace, PDF, CDF. And yeah, we have corresponding examples. We will have these examples. Now, the thing I'm going to go through is this guy, Gaussian random variable. Very important. And in chapter 4, this is the most important topic, Gaussian random variable. Make sure you know the parameters. Go through all the examples and homework problems. So make sure you know how to make use of this normal random variable, which is Gaussian random variable, CDF, PDF values. Don't worry about the subplots or plots. Okay. Now this Q table, do not forget to bring this Q table. Q table, this table, and there is another table in case you have Q given in the form of 10 to the negative K. Okay. So you have this Q table, bring this Q table with you. So Gaussian probability distribution function we have example, and I have like several parts of this example. So I put this example as one of your homework example level. This is not from the textbook, so but I did organize it nicely for you to practice how to make use of this how to make use of Q table and PDF of a Gaussian random variable to determine the probability. And actually, most of you did well in the Python code. So there was a Python related extractable problem, and most of you did fantastic actually. So forget about this conditional CDF PDF. I did not go through this conditional CDF PDF. And then expected value. Yeah, expected value of Gaussian random variable. Variance of Gaussian random variable. Variance of Gaussian random variable. And then the other thing that I wanted to go through is see the continuous random variable I summarized for from random variable, what is the PDF, what is the CDF, what is the mean, what is the variance. For exponential random variable, what is the PDF, what is the CDF, what is the mean, what is variance. And then for Gaussian random variable, what is the range, what is PDF, what is the CDF, what is mean, what is variance. Very important. And there are several examples that I went through related to that. And after that, functions of random variables. Functions of random variables, the most important part that you can think of is this example. This example shows how to make use of these functions of random variables, these two steps. Okay? So this example is not from the textbook, so I just made it up. And I have the solution for this example. I went through the solution of this example in class. So we have similar example here for different functions. Method of transformation. Here, very similar to the previous topic. Very similar to the previous topic. So we have linear transformation of Gaussian random variable. So we have y equals ax plus b. Again, all related to the Gaussian random variable. So as I said, that Gaussian random variable is very important. So we went through the linear transformation, and it's very useful in real life. So this example, you go through this example, and after that, I put some Python code. So I think it is a generative AI code. So this sort of Python code. And here you mainly focus on the command like norm.pdf, empty linspace, and then how to define parameters, how to come up with the equation. See, so these equations are given, but how do you write when you implement it in Python? So yeah, that's all. That's all from chapter 4. So forget about from like I-194, forget about from this slide all the way. Actually, I did mention several times, I did not go through all of this. All the way I-204. So you got we don't go through these slides a lot because I did not put everything on this slide. Now chapter 5. So chapter 5, we went through two random variables, but the most important topic that I'm going to go through is, do you see the joint PDF of two continuous random variable and joint CDF of X and Y? So you focus on CDF, PDF of two random variables. So forget about, like I should not say forget about these slides in case you have some true false type questions, but you focus on, as I said, that joint CDF of XY, joint PDF of two continuous random variables. So I'm going to go through those topics directly. Yeah, so here. Yeah, joint CDF of X and Y. So joint CDF of XY, we went through the theory. So make sure you go through these examples. Okay? But one example that I had, that was a huge example, but I'm going to scale it down in case I have give this CDF, joint CDF problem in class. Okay? As you can see, I have a lot of empty pages that I went through. So how to come up with 2D plot? You cannot, in the exam, you cannot put graphical plot, but I may ask you to just put it in tabular form. So after that, we have joint PDF. Joint PDF, probability density function, very important, but I am going to mainly focus on this sort of problem. So a randomly selected point in the unit square has uniform joint PDF given by this joint PDF, find the joint CDF of X and Y. Okay? So this slide, which is I-152 joint, I'm talking about joint PDF, very important. And then we went through, remember that we went through the ECE class. Okay? And the other important topic is joint PDF, but jointly Gaussian random variable. Very important. Jointly Gaussian random variable, you go through this topic and corresponding examples. And then finally, independence. So I'm talking about independence of two random variables. How we check independence of two random variables. Yeah, so this was a nice numerical example. So how we check independence of two random variables. After that, we did talk about jointly Gaussian random variable. Again, I'm reiterating jointly Gaussian random variable. Functions of two random variables. So we have functions of two random variables. Functions of two random variables. These functions of two random variables very important. So we have functions of two random variables and see the parameters, how we use the parameters and how they affect the parameters, and therefore they impact directly to this vector form equation Fx, which is jointly Gaussian random variable and their covariance matrix, mean vector and then covariance matrix. And then all of these are used in the final example. There was an example. Okay, here it is. All the topics on joint PDF of two continuous random variables. I actually summarized all the topics into this example. This example has 5 parts, and just for convenience, what I did, last year I had to go through manually, but this time I actually typed the solution, complete solution. So, again, please do not skim over the solution. Make sure you take a piece of paper and solve this example. And this example covers basically all the topics of this chapter mainly on joint period. Okay? So this joint period, joint probability density function, joint period is very, very important in real life. Very important in real life. So I spent some time to summarize all of this through this example. Make sure you go through this example and don't forget, like, the part of this example are given in the previous numerical example as well. But again, just to reiterate, so all these examples, all the previous examples, if you solve, you will see all the previous examples are culminated into the 5 parts that I had in the main example of, which is main example, which is on slide number 278. Okay, so that way you will know how to check the independence, how to check the covariance, how to come up with correlation coefficient, how to check orthogonality, and how to check how to numerically determine the correlation coefficient. Okay, all of these are in these 5 parts of the exam. Okay, so just to summarize, that's all I went through this chapter. Just to summarize, that in chapter number 3, focus on the probability mass function and related problems. Chapter number 4, mainly Gaussian random variable and related examples of functions of Gaussian random variables and so on. And chapter number 5 is basically joint period. Joint period is more important than joint serial. Okay, so joint period and related topics, all the topics that I went through joint period in chapter number 5 are culminated in one example. Okay, make sure you solve this example and you come up with related problems, because in the exam I will not give exactly the same joint period. I may give some different joint period. Okay, and for more practice, you have been doing good job in the homework problems. Okay, we have been submitting, I see the page, submitting homework problems. So make sure those homework problems, you revisit those homework problems as part of practice. Okay? Any question? No? Yeah, that's all for today. Now, just a final remark that this course, even though, when I was in undergrad, like I went through this course as well, even though this course looks like a math course, but this course basically gives you an overview to go in multiple directions. In many different, you can apply the topics in this course in many different directions. Okay? Hold on to the topics and try to formally apply the topics that we went through in different areas. Even in your senior capstone project, try to come up with the matrix, try to come up with the performance matrix that related to probability statistics random processes. So that way you know how to apply such topics in different problems. All right, thank you guys, and then I will see you in the final, and good luck in your final.